Hi everyone. We're going to learn how to find oxidation numbers of elements and compounds in this video. And we've got maybe 4 or 5 rules to help us. The first rule is elements and compounds consisting of just that element have oxidation numbers equal to 0. So here are some examples. If you see something like cadmium solid, oxidation number is 0. Copper solid, oxidation number is 0. O2 gas, this is a compound consisting of just one element, oxidation number of 0. Hydrogen gas, consisting of just hydrogen, oxidation number of 0. Nitrogen gas, oxidation number of 0. Sulfur 8, oxidation number of 0. Solid phosphorus P4, oxidation number of 0. All of these substances consist of just a single element. They all have oxidation numbers of 0. The second rule is about monatomic ions, which have oxidation numbers equal to their charge. So I think we saw some examples of these in the previous video. Cadmium +2. It has a charge of +2. That's also its oxidation number. Copper 2. It has a charge of +2. That's also its oxidation number. Calcium +2 has a charge of +2. That's also its oxidation number. And this is also true in compounds. For example, the compound cadmium hydroxide, we have a monatomic ion, the charge is +2, that's also its oxidation number. Or how about copper 2 sulfate? Again, we have a monatomic ion, the charge of that ion is also its oxidation number. Or how about calcium perchlorate? Again, we have a monatomic ion. The charge of that ion is equal to its oxidation number, which is a +2. So the next set of rules are all about nonmetals. Oxygen, for the most part, is usually a -2, except in peroxide, and here's the formula for peroxide, where the oxidation number is -1. So as an example, consider water versus hydrogen peroxide. Here in water, the oxidation number of oxygen is a -2, but here in hydrogen peroxide, you've got this peroxide anion. The oxidation number of oxygen would be a -1. Hydrogen can have a couple of different oxidation numbers. It's a -1 when combined with metals, for example, as in sodium hydride or maybe calcium hydride. Here, the oxidation number of hydrogen would be a -1. In compounds where hydrogen is combined with nonmetals, its oxidation number is a +1. So examples might be H2O, H2S, or methanol. These are all nonmetals, or even sugar. Hydrogen, when combined with all of these nonmetals, would have oxidation numbers of +1 in all of these examples. And then fluorine is always a -1, no exceptions there. And then the final rule is that the oxidation numbers of elements in a neutral compound have to add up to 0. So let's see if we can do some examples. So they want us to find the oxidation numbers of the underlined elements. Let's do this first one, diphosphorus pentoxide. So they want us to find the oxidation number of phosphorus. So 2 times phosphorus plus 5 times the oxygen, those oxidation numbers have to add up to 0. So I might want to call the oxidation number of phosphorus X. Now, remember the rule for oxygen. It's almost always a -2 unless it's in a peroxide. This is not a peroxide, so it's a -2. So I think if we finish the algebra here, 2x equals 10. So x is a +5. That is the oxidation number of phosphorus in that compound. Let's try this one. Find the oxidation number of nitrogen in nitric acid. So we're going to take the oxidation number for hydrogen plus that for nitrogen plus the 3 oxygens, and those have to add up to 0. And again, I'm putting quotations around oxygen so you can distinguish it from 0. This is the number 0. This is a capital O for oxygen. So what is the oxidation number of hydrogen? Well, hydrogen is combined with nonmetals. It's going to have an oxidation number of 1. I'm going to change this N to an X, and then 3. What is the oxidation number of oxygen in this compound? Well, oxygen is usually a -2 unless it's in a peroxide. This is not a peroxide, so it's a -2. And now we can do the algebra. I think X is going to be a +5. So that is the oxidation number of nitrogen in nitric acid. Let's try HNO2 or nitrous acid. Again, we're going to add up the oxidation numbers for all of these elements. Our first element is hydrogen. It's combined with nonmetals, so it'll have an oxidation number of 1. I'm going to call this nitrogen X. And then I have my 2 oxygens. This is not a peroxide, so each oxygen is going to have a -2, and they have to add up to 0. And I think X, or the oxidation number of nitrogen, is going to be a +3 in this compound. Let's try a few more. So now we're going to find the oxidation number of chlorine in sodium perchlorate. Sodium is a monatomic ion. Its oxidation number is equal to its charge, which is a +1. I'm going to call chlorine X. And now I have 4 oxygens. Those oxygens are a -2, and these have to add up to 0. So I think X works out to be a +7 here. So that would be the oxidation number of chlorine in that compound. How about this one? Dichromate. We're asked to find the oxidation number of chromium. So I'm going to say 2x, where x is the oxidation number of the chromium, plus 7 oxygens. Well, each oxygen has an oxidation number of -2. And notice that in this example, the sum of the oxidation numbers is not going to equal 0. It's going to equal that charge. So I think we're going to have 2x equals 12, x equals a +6. So the oxidation number of chromium in dichromate is a +6. And let's do this last one for oxalate. They want us to find the oxidation number of carbon. So 2 times x, where x is the oxidation number of carbon, plus my 4 oxygens. Well, each oxygen is a -2, and those oxidation numbers are going to add up to this charge. So I think 2x is going to equal 6, so x equals a +3. That is the oxidation number of carbon in oxalate. So I think that's all for this video. I hope you get some practice on your own, and thanks for listening.